Okay, so I've started recording. Okay, so let me go over the objectives again. So by the time we finish, you should be able to conduct an internal self-assessment and document it. So when I say document it, it means that completing the checklist.
Charles, couldn't at all. They are still struggling a little.
Okay. Please go ahead.
This one.
Is anybody having a question on farm, please?
We present our checklist.
Come again. Baraka, can you repeat your statement or question?
Mr. Charles is trying to inform you that the farm network is bad.
Okay. But
so maybe you should just wait for them for a few minutes.
Okay.
For them to reconnect and
okay. Then let's wait for a while, because today's session is very important for the farms especially. So I'm pausing, and then when they are ready with a better connection, we can continue. All right. We should be able to do this at the end of the session today. We've lost somebody. Okay, I think it's Barasa. He disconnected his phone. All right. Okay, so you should also be able to adapt the necessary infrastructure. Okay, so this will be at management level, where management can look at more cost-effective ways of adapting to the required infrastructure. And you should be able to develop the needed documentation and records as far as GlobalGAP is concerned. So how do we intend to achieve these objectives? Okay, so the first approach is what we have done already. We've done the introductory training sessions on GlobalGAP requirements. So by now we have a general idea about what GlobalGAP is all about and the major requirements. Then today we are going to continue to have a little bit of a hands-on training on risk assessment. Even though we are doing it digitally, we wouldn't have the real experience of a physical training, but we'll try to have some practical hands-on training on risk assessment today. And then after today, there will be guidance and coaching session, but that will be at the management level, and maybe management can include some supervisors, where we are going to work together as a team to develop all the necessary documentation, plans and policies for LATC to meet GlobalGAP requirements. So this will be the approach. We have already done the first one through the other sessions. We will do the second one today, and then we'll follow up on the third one. So today, I want us to work a little bit in our various departments. So farm, if you can organize yourself to sit according to department, because we are going to do some exercises that will involve individual departments. So farm can organize themselves there according to department. And then we will do some hands-on things about risk assessment. So this is how we are going to achieve our objectives. So we are going to start by looking at internal self-assessment. And I believe this should just be something like a recap for us. Okay, but let me also make the following important points. That when you are using the checklist to do your internal self-assessment, you must answer to all the three types of control points. So the three types of control points are major masts, minor masts, and recommendations. Even though recommendations are not mandatory, but when you are doing your self-assessment, you are expected to consider it and see how you can comply with it as well. So your self-assessment, you must answer all the three types of control points. And you must use the latest version of the checklist, that is the integrated farm assurance. And you should also provide evidence of action taken concerning non-compliances identified during the internal self-assessment. So GlobalGAP is not only expecting the company to do a self-assessment, the GlobalGAP is expecting that when self-assessment is done, the company is going to take steps to correct any non-compliances which will be identified in the self-assessment. And the auditor will look at evidence to that effect. So please note it very well. You should have some action plan when after doing your self-assessment. Then the last point is about the external audit. So at the external audit, you are supposed to score 100% of compliances in all major masts. That means that when you take the checklist and you fail to meet even one control point, which is a major mast, you have challenges getting your certification. You have to score 100% at the external audit in all major masts. Now, when you come to the minor mast, you are expected to score at least 95%. Okay, so when you are doing your internal self-assessment, have this into consideration. However, the recommendations are not scored. So if you have 0% of recommendations, it doesn't matter, you can still be certified. But the major and minor mast, you must score 100% and 95% respectively. So this is the exam score. So let me put it that way. This is the exam score. So when you do your self-assessment, just take this into consideration. Okay, any question up to this point, please? All right, let's proceed. Now, I want us to look at adapting to infrastructure. There are certain mandatory types of infrastructure which must be available to support your compliance with some of the control points. Let me state that GlobalGAP does not specify the way the infrastructure should be designed, or the materials or whatever. The GlobalGAP does not impose a structure on you. They don't impose specifications on you. But what they do is that they give you some criteria which must be met by the infrastructure in question. So there are about 6 main categories of infrastructure that will be considered. Okay, so first, if you are doing produce handling, and LATC is doing produce handling, okay, so if you are doing produce handling, your produce handling unit is an important infrastructure. So for example, your pack house is a produce handling unit. It is a place where you handle the produce for packaging and all, and etc., etc. Storage, cold rooms and storage facilities are also produce handling units. Okay, so these are important infrastructure which must be in place for any company that is handling produce. Then sanitary facilities. So sanitary facilities, the typical case is toilets. And GlobalGAP has specifications about these toilets. Okay, so when you take the control point, you realize that there should be toilet available for workers at the production sites, that is on the field itself, and also at the produce handling unit. Okay, so toilet facilities are very, very important. And I can say that at LATC, I didn't see any problem, much of a problem with this. The storage for plant protection product. So we are talking about your chemical store. So this is also an important infrastructure for GlobalGAP certification. The place where plant protection products are stored. The storage of fertilizers. So fertilizers and plant protection products are not supposed to be stored in the same structure or the same location. It can be the same structure but different locations in the structure. Okay, but they are not supposed to be stored together. So we need to look at that, the storage structure or the storage infrastructure for fertilizers as well. Then for another one is changing room for workers. Okay, so workers can change themselves, especially workers that are in the produce handling units, especially those that are in the produce handling unit. Okay, so we are looking for changing rooms for them. Then mixing and filling area for plant protection product. So where do you mix your chemicals for application on the field? Where do you mix them? Do you have a structure for or a dedicated place where plant protection products are mixed and filled into the knapsack or whatever application equipment? So this is also an important infrastructure. So these are the major infrastructure requirements. Any other infrastructure requirement will only help you will only support your company to meet some of the compliance requirements. But these are specific infrastructures which have been provided for categorically in the requirements. Okay, so I call this the minimum infrastructure requirement. There can be additional infrastructure, but these ones are the primary ones which must be in place. And you don't need to spend so much money to do some of these things, because the standard is not telling you to build a produce handling unit of, let's say, 100 square feet or 50 square feet. The standard is not giving you those specifications, but the standard is expecting that your produce handling unit should fulfill certain criteria. And that is what you should be focusing on, how your produce handling unit will fulfill those criteria. If you come to your storage facilities, for example, your plant protection product storage facilities, the standard is expecting, whoa, we've lost the farm again. So can we wait for them, please? Timothy and Abraham, we've lost the farm again. So I'll pause, then we can wait for them.
All right.
Okay.
We hear you.
All right. So as I was explaining, you don't need to spend so much money on some of this infrastructure, because GlobalGAP doesn't impose the physical structure on you. GlobalGAP only gives you a criteria which which must be met by your physical structure. So for example, if you take the plant protection product storage, GlobalGAP doesn't tell you that your plant protection storage should be this big or that big, and you should roof it like this or roof it like that. But they have given some specifications which must be met. And it is up to the company to look at its resources and its condition and build something or develop a structure that will meet the requirement. So we are going to look at some practical ways where we can adapt to some of this infrastructure. So let us look at this, for example. So this is a chemical store. The picture in the middle is a chemical store. Okay, so this chemical store, if you go into the standard, the chemical store is supposed to have certain features. Okay, one of those features is that it should have hand washing facility for the users or whoever is accessing the chemical store. Now, this farmer, for example, doesn't have to go and build a pipe and water sink in this chemical store. The farmer just improvised a means of providing the hand washing facility, because GlobalGAP hasn't told you that your hand washing facility should be of this type or that type. All they are asking for is that the chemical store should have a hand washing facility. Okay, so you don't need to spend, you can adapt to the situation. Okay, so you can have the hand washing facility in the middle, or you can have the hand washing facility on my right. You can have this hand washing facility, this one. You can have this one or this one. It depends on your strength. It depends on the resources available to you. It depends on your budget. Because this hand washing facility on my left and in the middle is as good as the one on the right, because they all meet the requirements. Okay, so that is how to adapt to infrastructure. Let's look at another example. So this is a toilet facility. Okay, so the toilet facility on my left has its own advantages and disadvantages. And the one on my right also has its own advantages and disadvantages. They all come with different costs. So it is up to the company to look at what is feasible for you. Because this, if you take the toilet facility on my right, which is a physical structure, it means that if you have 5 different sites, you have to provide the toilet facilities on all the 5 different sites. But if you have the one on my left, which is a mobile toilet facility, you can move this mobile toilet facility with the workers who are working. So wherever the workers are moving to, the toilet facility goes with them. So it depends on your situation, and it depends on your budget, and it depends on what is feasible for you. GlobalGAP doesn't impose what you should use as toilet facilities, so long as it is meeting the criteria they have set in the requirements. Let's look at another example. So this is a produce handling unit. Okay, the one on my left and the one on my right are all produce handling units. They are pack houses. So this one, they are handling mangoes, and this one, they are handling pineapples. You see that the one on my right, they have built as a block washing area, which has been fitted with potable water through pipe supplies. And the produce is not allowed to enter the pack house. The produce is delivered at the reception area, and then it is put into the washing basin, and the washing is automated, and those inside will receive the produce as it's being washed. Look, we've lost farm again. We've lost farm again, so let's wait for them. Okay, so we were at the point discussing how to adapt to infrastructure. So as you can see on the picture, these 2 produce handling units are doing washing. They are doing washing. And you can see on the right, they have an infrastructure which is different from the one on the left. However, they are all adapted to produce washing. Okay, there can be other things like hygiene, microbial contamination, and etc., etc. But that is not what we are looking at the moment. We are looking at the infrastructure. And you can see that if you get all the other things right, including hygiene, microbial contamination, and all of that, the infrastructure on the left is as good as the infrastructure on the right. It depends on the budget, the strength, and the resources available to the company. Because GlobalGAP is not telling you how to construct your produce washing structure. It is up to you to know to construct a produce unit structure which meets their specifications, but which also meets your budget needs. Let's look at this also. So this is this picture, I took it from your company. So this is the chemical store compared to this chemical store on my right. Okay, so you see a difference between the chemical store as I saw it at LATC and the chemical store here. Okay, so I'll pause here, then we will look at the specification for a chemical store according to GlobalGAP requirement. So I'll project that right now, and then we'll compare these two. Okay, we'll compare these two and see which one is meeting the requirement and why it's meeting it, or which one is not meeting the requirement and why it's not meeting the requirement. So give me a minute, I will project the requirement for us to see right now. Okay, so you can see on the screen the requirement for the fertilizer storage. Okay, so this is CB 4.
Hello, Charles, we can't see anything.
Oh, sorry.
The screen is blank.
Okay, sorry. Let me stop sharing and reshare. Can you see now?
All right.
You can see now.
Yes, we can see now.
All right, good. Okay, so let me also announce that Augustina, my colleague, just joined us, just in case you heard an unfamiliar voice. That's Augustina, my colleague. Okay, so let's look at the storage. These are the specifications. Okay, they are not telling you to build a structure of this size or that size, but these are the specifications. Fertilizers are separately stored from the plant protection products. They are stored in a covered area. The area is clean. The area is dry. In an appropriate manner that reduces the risk of contamination of water sources, not together with harvested produce. And then they come and say, is there an up-to-date fertilizer stock inventory or stock calculation listing incoming fertilizer and records of use available? So these are the specifications. So they are talking about storage. So you should have a storage where fertilizers are stored separately from PPP. The place for storage is covered. And when you come to the control point, they give you further explanation about what they mean by covered. The covered area is suitable to protect all inorganic fertilizers, especially powders, granules, or liquids from atmospheric influence. Example, sunlight, frost, and rain, high temperature, etc. Based on risk assessment, that is fertilizer type, weather conditions, etc., plastic coverage could be acceptable. It is permitted to store lime gypsum, okay, so blah, blah, blah. So you see the way they are giving you information about how your fertilizer store should be. Okay, so you can have a 1 square meter fertilizer store, 2 square meters fertilizer store. Whatever structure you use as your fertilizer store should meet these criteria. Okay, so you can have a company, they are going to spend a lot of money to build a fertilizer store, but if the fertilizer store doesn't meet these requirements, it means that it will not pass the audit. You can also have a company that will try to even use, some companies even use old refrigerated equipment. So they have this big refrigerator system which is not being used, and they use it as their storage. It still meets the requirements. So GlobalGAP doesn't impose infrastructure specifications on you. They just tell you that when you have an infrastructure, these are the requirements the infrastructure should meet. So it is up to the company to make sure that the infrastructure they are having meets the requirement. Okay, let's look at the plant protection. Plant protection store. Okay, so this is plant protection product. Let's look at the storage. Okay, so this is plant protection product storage. And these are the specifications. Our plant protection products stored in a location that is, so all the ones following from 7.7.2 in a location that is sound. Then if you come to the compliance criteria, they give you some information about what they want to see when they are talking about a sound location. So they say the PPP storage facilities are built in a manner that is structurally sound and robust. Storage capacity shall be appropriate for the highest amount of PPP that is needed to be stored during the application season. And the PPPs are stored in a way that is not dangerous for the workers and does not create a risk of cross-contamination between them and other products. You see, so they have given you their expectation about what they mean by plant protection storage should be sound. So it is up to you to make sure that your plant protection store is meeting this requirement. Then they come to the next requirement. The storage should be appropriate to the temperature conditions. Then they give you the additional information. The PPPs are stored according to label storage requirements. Then they come, the storage place should be well ventilated. In the case of walk-in storage, the storage facility have sufficient and constant ventilation of fresh air to avoid buildup of harmful vapors. Then they come well lit. The PPP storage facility have or are located in an area which has sufficient illumination by natural or artificial lighting to ensure that the product labels can be easily read while on the shelf. Then they come located away from other materials. The minimum requirement is to prevent cross-contamination between plant protection products, and other surfaces or materials that may enter into contact with the edible part of the crop by the use of physical barrier. So they are telling you that the plant location product should be, the store should be located away from other materials. So they are telling you that what to do here. Okay, so you can use a physical barrier or you can do other things to meet this particular requirement. Then they come. Are all PPP storage cells made of non-absorbent material? The PPP storage facilities are equipped with shelving that is non-absorbent in case of spillage. Example, metal, rigid plastic, or covered with impermeable liner, etc. So if you have a storage facility with shelf, just having shelf is not enough. They are giving you what should pass as an effective PPP shelf. So you can read further about the requirement, but with even the few that I've read, let's go back to our structure and compare and see whether they are meeting the requirement. Okay, so this is our structure again. So based on the requirement, what can you say about the two structures? Which one needs more improvement and which one needs some adjustment? Anybody? I want a feedback from farm or from anybody who wants to contribute.
Charles, good afternoon.
Good afternoon, Barasa.
Yes, I think from the two pictures I'm seeing, both need adjustments and improvement. Let me start with the one on the left.
Okay.
Actually, yes, the one on the left means that if somebody maybe splashes water or anything, it will reach whatever is poured inside, and it will reach whatever is stored inside, meaning dust can seep in, water can seep in. It's well ventilated, yes, but I don't know if it's inside the building or outside a building. If it's outside the building, then it's a very wrong thing. Rain will reach those pesticides from rain drift. So the left one needs to be restructured altogether. And then the right one, I'm seeing under the door, I don't see any form of banding there. I think there is you can put something inside, or maybe if somebody opens that door, I could be able to tell how the door is made. It may not contain whatever is put inside completely in. I mean, I can't see the banding. Then I'm only seeing one side. I don't know if the other side has a ventilation. There's an issue of aeration. That's on the right one. So I can't tell much about it because I've not seen inside. But aeration is an issue. And under that door, I'm seeing an opening, meaning banding is an issue, which means that if whatever is inside spills, it will flow outside. And I'm also looking at the climbing, the steps that you climb in with. I don't know which ergonomics they use there to climb the stuff inside. I don't know if you can drive a wheelbarrow in if the stuff is heavy, and whether a worker will stumble on those steps and maybe fall down. I think both need a bit of improvement and restructuring. That's my personal opinion. Thank you.
Okay, thank you very much, Barasa. Any other contribution? Okay, let's proceed. So yes, that is very good observations, Barasa. So if you compare with the requirements, you see both of them are chemical stores, and they are supposed to meet the requirement. So you see that they say that the first, let me project again the requirement. Let me project again. Okay, so let's look at the soundness. Okay, the first thing is the soundness. The PPP storage facilities are built in a manner that is structurally sound and robust. Storage capacity shall be appropriate for the highest amount of PPPs that need to be stored during the PPP application season. And the PPPs are stored in a way that is not dangerous for the workers and does not create a risk of cross-contamination between them or with other products. Okay, so this is the first measure of soundness according to GlobalGAP. So let's come back. Okay, so if we want to apply the measure of soundness, you see that the one on my right, even if the metals makes the whole structure sound, it doesn't pass the test of cross-contamination, because whether or not things are stored closer to it, even the stuff in it, when there is any spillage or something, it's coming straight outside. Likewise, anything from outside can also get in, because the physical barrier is not sound enough. But the one on the right at least has in terms of the soundness and in terms of cross-contamination and stuff like that, the one on the right is any auditor will give it a good consideration. Okay, so that is how you adapt to your infrastructure. You have to look at the requirements and then make sure that based on your budget and availability of resources, you'll be able to build your infrastructure to meet the requirement. Don't go beyond the requirement. For example, somebody can build a chemical store which is automated. It has automated door, it has a clocking. These are additional things. Okay, these are additional things. But the minimum requirement must be met according to the standard. So that is how to adapt to infrastructure. Let's proceed. Okay, so this is a typical example, and when we come to the coaching side, we are going to look at some of these things in more details. Now, let's look at the issue of risk assessment. But before I continue to risk assessment, let me ask if somebody has any question at this point or any contribution to make. Okay.
I think you can proceed there. We don't have anything to add.
Okay. My colleague Augustina wants to ask a question. Augustina, please ask your question.
Thank you for the opportunity to ask this question. I wanted to know, I need clarity on the chemical store soundness. You said the one on the left, that's the metal one, wasn't too sound, but that of the right was sound. So I got confused a bit. So how sound is the one at the right? Is it the blue barrier we are talking about now, or the one that has been locked up?
Okay. If you want to measure the soundness, the standard gives you the minimum measure. So let me go back again to the standard. Okay, so you can see control point number CB 7.7.2 and soundness. Now they are giving you the measure of soundness. The PPP storage facilities are built in a manner that is structurally sound and robust. Storage capacity shall be appropriate for the highest amount of PPP that is needed to be stored during the PPP application season. And the PPPs are stored in a way that is not dangerous for the workers and does not create a risk of cross-contamination between them or with other products. So let's see the picture again. Okay, so look at the one on the left. So it doesn't meet the criteria of soundness in terms of cross-contamination, because things from in can come out and things from outside can easily get in. And that is not the same case for the one on the right. Are you clear?
Yeah, I get it now, but I want to believe that the one to the left, okay, so in other words, I'm still not clear because this is just one container which contains, I want to believe it just contains one chemical product. I want to believe so. And then this one has different chemical products. So the comparison here is not really sounding well to me, because at the end of the day, if let's say we had many chemical products with this, the one at the right, then how are we going to store it? This one is not right because of the different chemicals that are together. So we say, okay, cross-contamination. But here is just one product, if I'm right.
Here is not only one product. Here also, if you should get the opportunity to go in, it has shelves and other chemicals just like this one. The soundness, we are not talking about what is inside. We are not talking about that yet. There are requirements for that. This one, we are talking about the physical structure alone, not what is inside. The interaction, what can easily go into the structure and what can easily come out of the structure.
Okay, that's fine. I get it now. Thank you.
Right. Okay. Please, any other question or clarification?
Maybe just on the same point, Charles. Okay. Maybe the reason why also Agustina is questioning the store on the right a lot, because we are made to understand of other features that combine together to make this soundness. Things like ventilation, which we have not really been taught. And you are teaching this in an African context. Within our Africa, we also look at other features which GlobalGAP may not really have heightened so much, like the safety of the pesticide. So when you see the wooden door alone, that raises issues of safety, like theft and burglary and whatever. And that eliminates the issue of soundness, because soundness is a broad term that refers basically to everything. Then we are also looking at that door that you have shown a little of it on the right. We don't know what that door is housing, and we know a chemical store is, a pesticide. A PPP store is supposed to be a stand-alone tool. We don't know if it's a companion of it, maybe storing things like like acid or fertilizer, or maybe it's the store for the handler of the pesticides where the PPE is stored or whatever. So unless we see exactly what that door is storing, we eliminate the issue of soundness a little until we see the wholesomeness of the whole thing. That's why maybe this questioning is coming about. Just an opinion. Thank you.
Yeah, I think you are very right on it. You are very, very right on it. At the moment, we can't see what is going on in there, or what is actually in the one on the right. Now, whenever you are, so Barasa, your issue comes to the point of interpretation of the requirement. Okay, now I want to go back one more time on the requirement. Then we can try to interpret it. I want to go back one more time on it. Okay, so this is, we are discussing CB 7.7.2 and the issue of soundness. Now, GlobalGAP have given you their criteria for soundness. The PPP storage facilities are built in a manner that is structurally sound and robust. Okay, so this is Barasa. The first statement is what you are talking about, that the soundness is, so when they say structurally sound and robust, what does it mean? Now you come to the second statement, then it's talking about storage capacity. storage capacity shall be appropriate for the highest amount of PPP that need to be stored during the application season. So the auditor will determine your total needs for the whole season. So let's say that for the whole season, you need, let's say, 1,000 liters of chemical in all. Your chemical store must be able to have the capacity to store 1,000 liters. If your chemical store doesn't have the capacity to store 1,000 liters, it still doesn't meet the issue of soundness. Then let's go to the next one, which has been my focus more. And the PPPs are stored in a way that is not dangerous for the workers and does not create a risk of cross-contamination between them or with other products. Okay, so I'm assuming in this training that the first criteria of capacity has been met by both. Then, so capacity, the first capacity have been met by both. Then, in terms of robustness, I'm assuming that both are meeting the issue of robustness. Now we come to the third criteria, and the third criteria is cross-contamination. The PPPs are stored in a way that is not dangerous for the workers and does not create a risk of cross-contamination. So, Barasa, let's grant both facilities the benefit of the doubt, and let's say that because we don't have additional information, we cannot answer the question of robustness and we cannot answer the question of capacity. But at least we can answer the third question, which is about cross-contamination, because that is more obvious here. So if we are answering the third question of cross-contamination, let me put the picture back again. If we are answering the third question of cross-contamination, you see that the one on the left is easily susceptible to cross-contamination in both ways, both from inside the storage itself and also from the storage environment. Okay, and the one on the left has very robust physical barrier, which even though it's possible that cross-contamination can occur when the door is open or when there is access, but granted the way it is not easy to, even you can't even see the product, and the wall cannot easily be broken, and even the wooden door itself, the wooden door itself provides a barrier. But we can talk about, I'm assuming that in terms of robustness and in terms of capacity, they are all meeting those requirements. So we are coming to the third one, which is about cross-contamination. And that is very obvious that amongst the two, the one on the right, which is the block, the brick and mortar structure, does not lend itself to easy cross-contamination at all, as compared to the one on the left. I hope I'm coming home now with you, please.
Agreed, Charles. Agreed. But let's move forward. Agreed. Totally agreed. Thank you.
Okay, great. So let me end by saying that when you come to adapting to infrastructure, the way you interpret the requirement can let you spend more or less. Okay, so Barasa, if you talk about the door being a wooden door and all of that, GlobalGAP is not telling you that your door should be made of wood, or it should be made of metal, or it should be made of glass. But you have to make sure that whatever door you have put there, you can justify why you have put it there in terms of the criteria that they have set. Okay, great, let's proceed. Now we are going to look at risk assessment. And risk assessment is also an important requirement in GlobalGAP. It is as important as the infrastructure. And even in some cases, your result of risk assessment can dictate the way you should build your infrastructure. Every decision that you take as a company when implementing GlobalGAP requirement your risk assessment should be able to speak on its own to the auditor for you. When you bring your risk assessment results to the auditor and the auditor looks at it, the auditor should be able to see why you have taken certain decisions. So risk assessment is very important here. In our previous session, we tried to explain or define what risk assessment is. And if we will recap, we said that risk assessment is a process of estimating the probability, frequency, and severity of the occurrence of a hazard. And we said that in GlobalGAP, there are three main areas of interest when we are talking about risk assessment. We are talking about we are referring to issues that affect food safety, issues that affect worker health and safety, and issues that affect the environment. So these are the three main areas of interest of risk assessment when we are talking about GlobalGAP implementation. So this is just by way of recap. Now, if you want to do a good risk assessment, you need to know what a hazard is. So what is a hazard? Okay, in order not to waste time, I would put the definition up. So hazard is simply anything that can harm you or your product or the environment. So this is the basic definition of a hazard. Then let's look at what a risk is. Okay, so in other words, we are talking about anything that can go wrong for your safety, the safety of the product or the safety of the environment. So when we are talking about hazard, this is all that we mean. So some examples of hazards in your production are the plant protection products, the produce storage environment, the environment itself, the source of water, the machinery and other farm equipment that are in use. All these are examples of hazards in your operations. So let's look at these pictures here. You see the first picture to my far left. This is a water body. It's like a dam or a stream. Okay, so this can be a source of hazard because the water can produce microorganisms which can be transferred to the produce. So in terms of food safety, it is a hazard. Again, it can also be hazardous to even other animals that can come and fall in and drown, or even the workers themselves. Okay, so this is a typical example of a hazard, your source of water. And mainly we are talking about microbial contamination. Then the produce storage environment. The way you store your produce can themselves be hazards. Even the containers in which the produce are stored. This picture is a tractor which has turned. Okay, it was plowing and the place was very steep and the tractor fell over. So that is this picture. So the tractor is an equipment. It is a potential hazard to the one operating it. Okay, and even as it fell, you see that it has fallen on the produce and it has damaged, destroyed all the crops under it. Aside that, even the tires of the tractor can be a means of transferring foreign material from one side of the farm to the other side of the farm. So as a farm equipment, it is in itself a hazard. Then your plant protection product is also a hazard because it can be poisonous to the one using it, it can poison the environment, and it can contaminate the product for the consumer. Now, risk assessment, hazard and risks are friends there. So let's look at what risk is. So the risk is the likelihood that the hazard will occur and the severity when the hazard occurs. That is what we mean by risk. So when you have a hazard or a potential hazard, it doesn't become a risk on its own. Your risk is the likelihood that the potential hazard can occur and the severity when the potential hazard occurs. Let me pause here for questions before I continue. Augustina, do you have any question? I can see you in the chat. Go ahead, please.
Yes, I have a question. My question is from the definition of what we saw as a hazard. We said anything that can harm you, the environment, or what else? That was what we saw for
the product.
Yes, and then in the pictures that you were showing, we
Yeah.
saw some examples of hazards where the water source, the source of water could be a hazard.
Yeah.
The equipment is also a form of hazard. It could be a form of hazard, and then the chemicals there. But my question is with the second picture in the storage room where you have your produce stored. How is it a hazard, or how does that describe hazard?
Okay. So if you look at the definition of hazard, we are talking about anything that, let me go back to that. Hazard is simply anything that can harm you, your product, or the environment. In other words, hazard is anything that can go wrong for your safety of the product or safety of the environment. So when you come to the second picture, so here we are talking about the storage environment and hazard in terms of the product, not necessarily in terms of the worker. But even here, you can still see some potential hazard because of the height. Look at the height of the crates, okay? And you can see that the crates, some too have not been stacked effectively. It can easily fall over, the one bending there, assuming he pushes himself a little bit, okay, and he's not careful, it can easily fall over. But that aside, let us even look at this is green pepper, okay? So this is green pepper. So you are looking at the entirety of the storage environment. The crate that is being used to store the green pepper, okay, what harm can it have on the product? And there are a lot of things that we will look at when we are doing the risk assessment. Typically, you have to even answer the question, is the crate having any chemical which can be transferred to the product itself? So there are so many questions that come in mind when you are talking about even the storage environment. So this picture is there to illustrate to you that when you are talking about hazard, it can be just anything, even things that you are not having in mind. These crates might have been used to transfer something, and they are storing the sweet pepper or the green pepper in the sweet pepper in it. Okay, so the crate can be a potential hazard. We are not saying that the crate is having microorganisms in them, or the crate has been used to transfer some chemicals previously. But we are saying that the fact that the crate can be used for such purposes, the crate is potentially a hazard. We are not saying it has occurred yet. And that takes us to the next stage, which is risk. Risk is the likelihood that the hazard can occur. So the crate, yes, the crate can be a source of cross-contamination, but is it really a risk? So that is the second part. So hazard can be anything, even you, the human being. You can be a hazard to your fellow human being, but have you really become a risk? You, the human being, you can transfer germs on your hands to the product as he's touching the product, but are you likely to do that? So that is the difference between a hazard and a risk. Hazard is anything, just anything that can cause harm to you, the product, or the environment. But as to whether the harm will occur is another question. And when you are talking about that, then you are going into the area of risk. Are you okay, Augustina, please?
Yes, please. I'm very fine now. Thank you.
All right. So yeah, please.
Again. Just a question.
Please go ahead.
I'm kind of getting confused a little, and I request for clarification, please.
Okay.
If hazard, we have said is anything that is at any place, and we have said that not that a hazard can impact on us only negatively or no. I mean, it could be there without giving any impact on us, or it might give a negative impact or even a positive impact to health. Then now we go ahead and define a risk as a likelihood that the hazard will occur. But we define the hazard as not really.
Come again. Hello? Hello, Barasa. Are you connected? Have we lost Farm again? Farm, are you there? Hello, Farm. Wow, seems we've lost Farm.
Get in touch with him.
Hello, I lost you guys. I'm back now, sorry. Okay, so let me, Barasa, can you please repeat your question? Because I didn't get the later part of it.
Okay, let me come back, Charles.
Okay.
Are you getting me?
Yeah, I can hear you.
Maybe if you go back to where you had displayed risk, then
Okay.
My question framed, please, yeah.
Okay, let me go back.
Yes.
Okay, this is hazard.
Mr. Charles, I think
Yes.
the host has been assigned to me, so I would love to leave, then make you the host back.
Okay, come again, please. Timothy.
I think the host now has been assigned to me. It's only my screen that can show.
Okay,
Yes. Hello.
Okay, let me
The host has been assigned.
okay. Let me go. You can still remain it. You can still remain the host. I can
Okay, all right.
yes, I can still share my screen again. Okay, can you see my screen now, please?
Yes, we can see your screen. We can see your screen now.
Okay, great.
Yes, I can see now.
Okay. So, Barasa,
now,
I would like you to repeat your question.
Yeah, look at your definition of the hazard.
Okay.
It's simply anything that can harm you.
Yes.
Meaning, if you put the word can, it means a hazard can be either harmful or harmless.
No, a hazard is potentially harmful. Anything that is potentially harmful.
Then why now? Why now? I raise a question is when you went to the definition of a risk.
Okay, let me go there.
Yes.
So this is the definition of a risk.
Yes, that the risk is a likelihood that a hazard will occur and the severity when it occurs.
Yeah.
So that was where I was getting a bit confused.
Okay.
That a hazard can be harmful or harmless. Then how we can find a risk as a likelihood that a hazard will occur?
Okay. So this definition, this.
I'd like to clarify that. Can you clarify that?
Come again. Okay. So this definition, because I'm not teaching you risk assessment, I'm just trying to give you a basic understanding. This definition of a risk can even be put in mathematical terms, but we will not go there yet. Because you are saying that you have a hazard. Let me give you a typical example. Your mobile phone. Your mobile phone is a potential hazard. It can harm you. For example, when the screen cracks, when the mobile phone is in your pocket or any part of your body, and you hit a wall or something hits it, and the screen cracks, the glass can harm you. But what is the likelihood that your screen will crack? And when your screen cracks, what will be the severity of the harm that the mobile phone will cause to you? These two things combine together to give us risk. Risk is always the likelihood of occurrence and the severity of the harm. Let me give you another example. When you take ordinary alcohol, which can be taken in by humans, the ordinary alcohol is potentially harmful. When you take another plant protection product, let's say a weedicide, the weedicide is also harmful. But when you have alcohol on your farm and a weedicide on your farm, you don't use alcohol for your plant protection activities. But the fact that the alcohol is on your farm in a gallon or in a bottle, the alcohol itself is potentially harmful to when you use it badly on the crops. But what is the likelihood that you will use alcohol on your crops, even though the alcohol is there, compared to the likelihood that you are going to use a weedicide on your crop? So both are potentially harmful, but it is not likely that you are going to apply alcohol on your farm as it is for your weedicide or your pesticide. So this is what we are talking about here. We are talking about something that is there, which is potentially harmful, but you need something to trigger the thing to cause the harm. The likelihood that the thing can cause the harm or the thing will cause the harm, that is what the risk is about. So if you have a hazard, if you have a knife with you, until you are likely to use the knife to harm somebody, it is not a risk, but it is a potential hazard. So that is what we are talking about here. I don't know if I'm coming along with you.
Copied, Charles, copied. It's clear now. Thank you.
All right, thanks too. Please, any other clarification or question? Okay, we'll proceed. So let me give you a typical example. Okay, so I have an example here. Crop protection products are potentially harmful substances to the worker and can contaminate the environment and the product. All crop protection products are potentially harmful substances to the worker, the environment, and the product. But they are essential for farming and are used all the time in crop production. Therefore, the likelihood of a hazard occurring from its use is high. Plant protection products can cause food poisoning or serious health effects on the worker. It can also kill other organisms in the environment. So this is what I've elaborated before from the questions that were asked. Now, let's focus on the mandatory risk assessment in GlobalGAP. With this background about what a hazard is and what risk is, we are going to focus on the mandatory risk assessment. Risk assessment can be used in every aspect of your operations, but certain types of risk assessment are mandatory. You cannot get GlobalGAP certification without doing those risk assessments. And these ones are clearly stated in the requirements. So if you take your checklist, you see this mandatory risk assessment, and this has to be conducted by the company, and the auditor will have to see the records. So I want to take my time to go through it one after the other, mention it one after the other. If you have your checklist, you can read the control point itself in the checklist. So you have site or new site risk assessment. So your site, your production site, especially with the open field, before you start producing there, you must have conducted a risk assessment. Then hygiene risk assessment. You have to conduct a risk assessment with respect to hygiene, all aspects of hygiene, personal hygiene, environmental hygiene, hygiene of equipment, and all of that. What is the possibility that a hazard can occur because of hygiene issues? Then health and safety. So you have to conduct risk assessment to see whether there is any hazard or risk to the health and safety of the workers. Then you have to conduct risk assessment on food defense. And we talked about food defense the other time, that food defense is the intentional adulteration of food or intentional contamination of food with the aim of causing harm to the consumer. So for example, I gave an example and I said that those in the area of Boko Haram who are farmers, it is possible that Boko Haram can come and spray poison on all the crops in a particular farm without them knowing. That is a food defense issue. So how can they defend themselves against intentional contamination? So you need to do a risk assessment to identify all the potential harms which can arise as a result of food defense issues. Then food fraud. You need to do a risk assessment to identify all potential hazards and risks that can come as a result of food fraud. For example, if somebody happens to sell a fake plant protection product to you, or you buy a fake seed from the market, you need to do a risk assessment to identify all the potential hazards and risks there. Then fertilizer storage. Okay, so I think we saw it earlier on that you need to do some risk assessment on your fertilizer storage to see the potential hazards that can contaminate the fertilizer and the vice versa. Then risk assessment on organic fertilizer. So for companies that are using organic fertilizers like poultry manure, cow dropping, and all of those, you have to do a risk assessment on the organic fertilizer to identify all potential hazards and risks associated with it. Then water environmental risks. So if you have any water in your production environment, whether a stream, a river, or borehole, or any source of water on your production site or in your production environment, you need to do a risk assessment on that to identify all the potential hazards and harms which you can cause on the water or which the water can cause on your operation. Then sewage water. So this sewage water clause or control point is applicable to only those who are using treated sewage. So if you are not using treated sewage, it's not applicable to you. Then water quality and physical and chemical contamination with water. So this is in respect of water that is coming into direct contact with the produce, like water for washing the produce. You need to do risk assessment on it. Then residue. So the chemicals you are using, the plant protection product, insecticide, weedicide, and other chemicals that you are using, you need to do a risk assessment to know whether there are any potential hazard in terms of residue of those chemicals. Then health check. Okay, so this one is for only workers who are handling plant protection products, like the sprayers and those who work in the store. You need to do their health check for them. This one, you are not supposed to do your own risk assessment. You need to take them to a accredited medical institution for their health to be examined to ensure that their work by way of being sprayers or working in the chemical store or handling chemicals does not pose any hazard or risk to their health. So this kind of hazard, the one in CB 7.8.1, that one is not supposed to be done by you as a company. You are supposed to take your workers to a medical facility for medical examination to be done on them. This is only for the sprayers and those who are handling chemicals. And the auditor will check their medical records. Then sites. So this one, we are talking about the production site and the produce handling unit. You need to do microbial risk assessment to identify any potential microbial risk on your produce. Then you also need to do microbial risk assessment on all water sources that are coming into contact with the produce, especially the produce handling unit or your pack house. You need to do microbial risk assessment to see the potential microbial risks that can occur. Then hygiene. You also need to do hygiene risk assessment. So this is hygiene in terms of all aspects of it. So workers' hygiene or personal hygiene, environmental hygiene, hygiene of the equipment or tools that are being used, and so on and so forth. So these are the mandatory risk assessment records which must be sent during the audit. All other risk assessments can be done and they can be additional, but these ones are mandatory because they are specifically written in the GlobalGAP standard, and you are expected to do the risk assessment on it. So the team that I'll be working with later on, we will try to do some of these things. But today, I want us to go a little bit practical into a few examples of how these things can be done. So if you take your control points and compliance criteria, you see an annex. So please open your control point and compliance criteria. If you haven't downloaded it yet, go to the website and download it. You see an annex where GlobalGAP is giving you some guidelines about risk assessment. It will be very, very important for you to read this, especially the supervisors in the various departments who will be doing risk assessment. Okay, so please download it, but I'll run you through a few examples. So I'll take one example, site risk assessment. So site risk assessment is about where your crops are being grown. That is what we mean by site risk assessment. So site risk assessment doesn't take into consideration the pack house. It takes into consideration the site where the crops are being grown. And when I came to LATC, I realized that you are growing crops in two main ways. You are using the greenhouse production and open field production. So the greenhouse becomes a site. It becomes a production site. And not all the greenhouses put together, but each individual greenhouse becomes a production site. And then the open field also is another production site. So you are using two production methods and both have to get their own risk assessment. So let's look at the greenhouse. When you are doing site risk assessment for the greenhouse, you have to consider two main questions. Is the greenhouse suitably constructed for the crop, for crop production and suitable for the particular crop? Are there any factors in the immediate surrounding that can affect the intended use of the greenhouse? Now, let me take you back to the checklist and let's see what the control point is saying. I want to take you back to the checklist on site risk assessment. Okay, so this is the control point on site risk assessment. Okay, so here is it. Is there a risk assessment available for all sites registered for certification? This includes rented land, structures, and equipment. And does this risk assessment show that the site in question is suitable for production with regards to food safety, the environment, and health and welfare of animals in the scope of the livestock and aquaculture certification where applicable? Then you come to the compliance criteria. So this is the expectation they have. A written risk assessment to determine whether the sites are appropriate for production shall be available for all sites. It shall be ready for the initial inspection and maintained, updated, and reviewed when new sites enter into production and when risks for existing ones have changed, or at least annually, whichever is shorter. The risk assessment may be based on a generic one, but shall be customized to the farm situation. Risk assessment shall take into account potential physical, chemical, and biological hazard, site history for sites that are new to agricultural production. History of 5 years is advised, and a minimum of 1 year shall be known. Impact of proposed enterprise on adjacent stock, crops, environment, and health and safety of animal in the scope of the livestock and aquaculture certification. See annex. So they are referring you to their guidelines. So this is what the auditor will come and check in terms of site risk assessment. They are looking at the suitability of the site for crop protection. They are looking at the fact that the site does not pose any hazard or risk to workers, the product, and the environment. And they are expecting that the hazard to identify all physical, chemical, and biological hazard. I mean the risk assessment, sorry. The risk assessment should identify all potential physical, chemical, and biological hazard. And it should also take into consideration the site history. This is important for open field production. I think greenhouse production, site history is important if you are using your greenhouse you've been using your greenhouse for a long time. Okay, so let me go back and show you how to do this one. Okay, this particular risk assessment. Let me show you how to do it. So for the greenhouse, you need to answer the question, is the greenhouse suitably constructed for production and suitable for the particular crop? So you know that greenhouses are constructed for particular, how do I call it? Weather condition. Okay, weather and even they are in terms of temperature, in terms of environmental conditions, greenhouses have specific factors which are used in their construction. So the greenhouse that you are purchasing for, or the ones that you have purchased, or the ones that you intend to purchase for your product or for your production, whatever crop that is going to be produced in the greenhouse, has the greenhouse been designed and constructed to be able to produce that crop? So that is the first question. And this one, the manufacturer should be able to give you a lot of documents to show as proof. So you can get it from your manufacturer. And then even the environment in which the greenhouse is located. Are there factors in the immediate surrounding? For example, do you have strong winds which can affect? Do you have too much heat or too much sunshine? These are things that you have to consider. These are very, very important things that you have to consider. And you can answer them in the risk assessment. And finally, in terms of worker health and safety, are there anything about the greenhouses that can pose threat to worker health and safety? So these are things that will be answered. Any question or contribution up to this point? Okay, so you can see on the screen, this is a typical example of a risk assessment. Okay, risk assessment, you can present it in several ways, but this is just one example. Okay, so here, this is a site, an example of a site risk assessment for open field production, not for greenhouse. This is for open field. So first, we want to identify all the vectors or all the factors which are potential hazards. So by now you should know what the hazard is. So first we identify it for the particular site. So this was done for a particular site. Every site can be different, but this is for a particular site. So water is one, soil is another, animals, planting materials, vehicles, personnel, tools and equipment, etc., etc. And then after we identify the factors, we try to identify the root of contamination. So how can water contaminate the product? So this is in particular with respect to the product. How can water, by what means can water contaminate the product? And irrigation, washing, mixing of the input and flooding. So these are the means by which for that particular farm, water can cause harm to the product. And we wanted to identify the potential point, at what point in the operation can the hazard occur, or can whatever contamination that is expected occur. So for irrigation, yes, irrigation can occur on the field during the growing process. Then on the field, during harvest. So during harvest, there is no irrigation. So irrigation is not an issue there for field during harvest. During packing, there is no irrigation, and during transportation, there is no irrigation. So we have been able to identify that there is a potential hazard in the form of water, which can affect the crop or the produce through irrigation, but it can occur only on the field during the growing process. Then water at washing. So you don't wash the produce when you are growing them, you don't wash the produce when you are harvesting them, but you wash the produce when you are packing them. You don't wash the produce when you are transporting them. So in that case, we see that in terms of washing, water cross-contamination can occur during packing. Then flooding. So when there is a heavy rain or when any dam breaks up and there is flooding for that particular farm, the way their structure is, it means that the flooding can affect every aspect of their operation. Every aspect, because of the way their structures are at the time. So for flooding, but the likelihood that flooding will occur is also very, very low. We'll look at those ones. Then soil. How can soil be a source of contamination? So when the produce come into contact with the soil, and when can that occur? That can occur during growing, and that can also occur during harvest. But for them, for this particular farm, the way their operations were organized, it isn't possible for soil to touch their produce when they are packing, because the whole place is enclosed and cemented. So unless a worker comes in with something that can have soil on it to contaminate the product. But from what they had at the time, it wasn't possible that soil can contaminate the product during packing and also during transportation. So for LATC, for example, what I saw on your farm is when you are transporting your product, it will not be possible for soil to contaminate it because you transport your produce in cold vans. So that one is not possible at all. But for a company that transports their produce on open tracks, okay, open tracks and not in cold vans, the dust on the road and stuff like that can cause potential contamination. So this is the first step. You identify all the potential vectors or factors of cross-contamination. And then you identify the various routes, the means by which they can cause cross-contamination. And then you identify the stages of the operation where the cross-contamination can occur. So this is a typical example of site risk assessment in terms of microbial contamination. Now that we have identified it, we have identified this route, you come to, let me show you another template. Give me a minute. Let me stop sharing first. I want to show you another one. Okay, so this is another one. Okay, so this is another one. So this one is for the pack house. So this is risk assessment on pack house and holding areas. Now these are the factors that we assessed: hand washing of workers, use of jewelry and ornaments by workers, long and dirty fingernails of packing workers, communicable and airborne diseases, use of personal protective clothing, availability of potable water, eating and drinking at work, smoking, work surfaces and parking tables, people living close to the pack house, weeds and bushes near the pack house, physical separation between the parking area and the immediate surrounding. So these are the factors that we identified. Okay, so this is how they were assessed. Hand washing. No hand washing facility available in the pack house and at the holding area. Is it a risk? Yes, we realize that it's a risk. Why is it a risk? Then we identify why it's a risk. Biological hazard due to contamination of products with hands infested with pathogens. Then the mitigation measure. Hand washing facilities are available always during packing. Workers receive training and instructions on hand washing. So this is a basic or a very simple approach to doing risk assessment. Very simple approach. So when we are working, when the team is working, these are some of the things we'll be doing. These are some of the things we'll be doing. We'll be doing it in context of LATC. Let's look at the one on inorganic fertilizer. Factor to assess: records on fertilizer application. Okay, all fertilizer application activities must be documented and records kept. Records of fertilizer application activities are available and kept up to 2 years. Then the action: provide training to personnel carrying fertilizer application activities, when and who. So this is an action plan that we developed based on the risk assessment that we conducted. So you don't need to do a whole dossier of literature when you do your risk assessment. Your action plan can be as simple as this. As simple as this. Whenever you identify any risk, your action plan can be as simple as this. It doesn't have to be a whole documentation of dossiers and stuff like that. And there are several ways of looking at it. Now let's look at food defense. I mentioned food defense is one of the new areas. Let's look at an example. What are the hazards? So we identify the hazard in terms of food defense. Unauthorized people on the property or on the fields, contamination by plant protection products, receiving contaminated product at the facility, dangerous machinery, unauthorized people at the facility. I think it's a repetition. Okay, so here let's look at what we said. Unauthorized people on the property. Who or what might be harmed? Workers and the product might be harmed when unauthorized people visit the facility. And we assess the level of the risk as medium, because based on the way the company was structured, it wasn't easy for unauthorized people to come there. So we assess the risk as medium. But for a company where their structures are in such a way that unauthorized people can come there without even being identified, then the risk level will be very high. Then precautions to take: when financially or logistically feasible, fence the property. Post no trespassing signs that direct visitors to sign the visitor logbook. Have visitors announce their presence on the property by signing the visitors log. Post rule signs on property where visitors can read them. So these are the measures that were supposed to be taken. So they have to, if they had money and if their budget could allow, fencing the property was the best. But if they do not have the money to fence the property, they can post no trespassing signs there along their boundaries for people to be aware that they cannot trespass the property. And visitors who visit the property are to sign a visitor's logbook so that everybody who comes to the property can be tracked in terms of if something should occur. Okay, so this is a simple action plan which was developed based on risk assessment. Let's look at contamination by plant protection products. Who can cause this contamination? Workers and visitors on the farm. What is the risk level? It is very low, because from that company, the way they've structured their processes and procedures, it wasn't easy for anybody to enter there holding a plant protection product and it cannot be detected. Okay, and what are the measures? Even though the risk is low, they still provided some measures. The PPP storage areas is locked or fenced and used only for PPP storage. Signs are posted stating pesticide application. Workers and visitors are prevented from re-entry to fields until the re-entry period has expired. Stage a decontamination area near the mixing station and stock well with supplies and stock well with supplied wash-off chemicals if an accident occurs. Okay, so this is the simple measure that they took in terms of food defense when they identify potential contamination as one. Okay, so these are simple things that can be done. They also had a dam. Let's look at the dam. The risk assessment in terms of the dam. The source of hazard, agronomic or crop protection activities can be a source of hazard to the dam. Then the description of the hazard. Improper application of the pesticide, throwing empty chemical containers into the dam, washing spray equipment in or near the dam, spillage from chemical mixing platforms near the dam. The measures they were to take: no washing of empty pesticide containers in or near the dams. Chemical mixing platforms should be constructed not less than 100 meters away from the dam. Mixing platforms near the dam should be raised above the ground. Washing of knapsack and empty containers of plant protection products are not allowed in or near the dams. In case of any spillage during mixing, spilled chemicals should be appropriately collected. Then they brought a procedure. Workers responsible for mixing and application of PPP will receive training in good crop protection practices. Mixing platforms will be constructed at least 100 meters away from all dams and water bodies. Workers will be trained to follow appropriate instruction during application. So this is in context of that particular company. Okay, so this is how risk assessment should look like. An example of how a risk assessment should look like. So I believe that by now we are getting a clearer picture, and when we go into our team meeting, we'll have a better understanding of how to do these things. Okay, please, any question up to this point, please? Any question? Fam, do you have any question?
No question, Charles, as you are following on well.
All right. Okay, so today, our time in terms of the connection challenges, we have already spent 2.5 hours in total. Okay, since we connected, but the connection challenges have been one of the reasons. But I intended that we were going to have done this small assignment, but because of time factor, I wouldn't want to bother us at all with this, since we'll be working in a team later on some of these things. So I wanted us to, so I identified some risk factors here, and I wanted you to explain why they are risks, and also give any measures that is needed to be taken. So, but we will not do this assignment because of time factor. I've already taken 2.5 hours of your time, and I don't want to take any more of that. We will work on the background with management and with the team that will be selected to produce some of these things that we have discussed here. So on that note, if there are any questions or contributions, I'll take them. If not, then we will bring the training to an end.
Yeah, just you are right, actually. We also have a bit of obligations here to carry on. Now it's our harvesting time, and most of the team members are impatient because we need to go and harvest. And we have also been around for long. In that period you have mentioned, the concentration is a bit of going out. Maybe if we can pause there and proceed next time, that can be perfect for us. Thank you.
Okay, so thank you very much, Barasa. So we are ending the training sessions officially today. The next series of sessions will be coaching. It wouldn't be a training session, but we'll be talking about how to develop the document. I'll send you samples and you go to the field to do it yourself. then we come back to discuss it. But the training session, the capacity building session, and the introductory session, everything will end today. So before we end, let me give management praise, and Ayodeji, let me give them opportunity to give closing remarks if they have any, before we officially end the training.
Thank you very much, Charles. Unfortunately, Ayodeji stepped out. Something came up, so he needed to attend to it. So he stepped out of the room. Well,
Okay.
Thank you for the patience and the time so far. We're very grateful for how you have taken us step by step and the way you've given us the opportunity to always interact. It's not a one-sided sort of training. It's an interactive session at least. So we're very grateful for that. Well, from our end, we are good. I don't know if Barasa wants to say anything from his end as well. Thank you.
Okay, thank you. Any closing remarks from FAM?
Not really much, but we have enjoyed your sessions a lot, Charles. The training has been fantastic, and we look forward to those coaching sessions, and we'll give it the much cooperation as possible. Otherwise, we want to say thank you, and we don't have anything else to add.
Okay. All right, then thank you very much. So on behalf of COLIECP, I also want to thank you on behalf of my project manager, Wester, and the entire project implementation unit of COLIECP. I would also like to thank you for your time. I know your schedules are busy, are tight, and yet you found time to take part in the training. And we are also grateful to you for your time and dedicating resources for this training. We are looking forward for the coaching session and for a very healthy and productive relationship with COLIECP. Thank you very much, and I wish you all the best. Bye-bye for now.
Bye. Thank you. Thank you.
Okay.
Bye.
Bye.